All right, so we're going to start this evening by looking at graphical solution of cos x is equal to k. Example 5 is asking us to, well, we're not really going to solve it graphically, but what I'm going to do here in example 5 is we're going to derive the general solution for cos x is equal to k. All right, so let's start. Example 5 says solve graphically the equation cos x is equal to k. Now, if cos x is equal to k, where k is less than 1, but greater than or equal, less than or equal to 1, or greater than or equal to minus 1, if cos x is equal to k, it means that x would be equal to cos inverse k. Now, let us say that the answer in the first quadrant for cos inverse of k is alpha. Please note that in the first quadrant, there is the trig ratio of every. All right, so I believe I was saying that in the first quadrant, the sine, cosine, and tangent of every angle in the first quadrant is positive. In other words, the sine, cosine, or tangent of every angle between 0 and 90 degrees is positive. So by saying that alpha is the answer in the first quadrant, I'm saying that k is positive. Because the cosine, if an angle is in the first quadrant, the cosine of the angle must be positive. So k is positive. Now, the next, so in other words, alpha is our reference angle. Alpha is our reference angle. Now, if alpha is our reference angle, and the next quadrant in which cosine is positive is the fourth quadrant. In the fourth quadrant, the answer is going to be 2 pi minus alpha. Now, back to the first quadrant. So that is the first 360 degrees. Now let's go to our second 360 degrees. Back to the first quadrant, the second 360 degrees, between 360 degrees and 720 degrees. The answer in the first quadrant is going to be 2 pi plus alpha. And then the answer in the fourth quadrant is going to be 4 pi minus alpha. Now, in the next 360 degrees, this is now from 720 onwards. It's going to be 4 pi plus alpha in the first quadrant. And in the fourth quadrant, it's going to be 6 pi minus alpha. All right, by now we should be able to see a pattern that the general solution for cos x is equal to k is x is equal to 2n pi plus or minus alpha. The general solution is 2n pi plus or minus alpha, where alpha is an element of the set of, where n is an element of the set of integers. So n is an element of the set of integers. All right, so example 6. Example 6 is asking us to find the general solution of cos x is equal to a third. So I have cos x is equal to a third. So it means that x would be equal to cos inverse 1/3. All right, so my reference angle, the the cosine inverse of 1/3. Let me just put that in my compute calculator. Shave cos 1/3. This says 70.5 degrees. So my reference angle is 70.5 degrees. And the general solution is x is equal to 360 degrees n plus or minus 70.5 degrees. That would be my general solution. Let's have a go on the general solution. There is in degrees. Let's have a look at example 7. In example 7, we're asked to solve the equation. No, so he's not specifically asking here he's not specifically asking you for the general solution. But if you're asked to solve a trig equation and they're not giving you a range to the answer, it is best to write your answer as the general solution. If you're asked to solve a trig equation and you're not given a range for the answers, it is best to write your answer as the general solution. So here I have cos 3x is equal to 0.5 or a half. Therefore, 3x is equal to cos inverse a half. And I think the cosine inverse of a half is 60 degrees. Now 60 degrees is pi by 3. So my general solution, I have 3x is equal to 2n pi plus or minus pi by 3. But we don't want the general solution for 3x. What we want is the general solution for x. So all I would do now is just divide the entire equation by 3. And if I did that, I'm going to get x is equal to 2n pi over 3 plus or minus pi by 9. If you divide pi by 3 by 3, you're going to get pi by 9. Pi by 3 is 60 degrees. Pi by 9 is 20 degrees. So if you divide 60 degrees by 3, you're going to get 20 degrees. If you divide pi by 3, you're going to get pi by 9.